Hello everybody. My name is K. Ravi. I am from TTWREIS Balanagar. My topic is gas laws. In this class, we are going to discuss about matter and classification, properties of solids, liquids and gases, gas laws, ideal gas equation, applications of gas laws in our daily life. Friends, shall we enter into our class? Yes. Friends, all of you observe, look at the picture. What do you observe in the picture? Yes, you determine all these things very spontaneously. In general, what we call all these things in the science? Yes, we call all these things in the science as matter. In this class, we are going to discuss about the matter. The word matter has a specific meaning in the science. Let us try to understand the concept of matter. So, in previous class, you have studied about metals, non-metals, acids, bases and synthetic fibers, natural fibers, etc. and etc. All these are the examples for the matter. The things around us, variety of shape, size and textures are all the examples for the matter. The food we take, the water we drink, the clothes we wear and even our body is also example for the matter. In science, the word matter is defined as anything in the world which occupies mass and space is called as a matter. So, matter can be defined as anything in the world which occupies mass and space is called as a matter. For example, if you consider this syringe, it has some mass and it occupies some space, therefore, it is called as a matter. If we consider this bowl, so bowls contains some mass and it occupies some space, therefore, it is called as a matter. There are many examples of matter in our day-to-day life. For example, stone, pen, pencil, books, table are all the examples of the matter. Friends, shall we enter into the next slide? Yes. Classification of matter. Friends, on the matter on the basis of physical properties, they are classified into three types. They are solids, liquid and gases. Matter can available in how many ways? In three different ways. They are solids, liquids and gases. Friends, shall we enter into the next slide? Of course. Friends, on looking at the things, we are classifying them into solids, liquids and gases. Based on what factor we are classifying them into solids, liquids and gases? Yes, on the factor of mutual force of attraction and their escaping tendency. We are classifying things into solids, liquids and gases on the basis of their mutual force of attraction and their escaping tendency. We are classifying the things. If you talk about the solids, in solids the mutual force of attraction is higher than their escaping tendency. The things around us which have mutual force of attraction is higher than their escaping tendency, we classify those things into solids. For example, pen. It is in pen the mutual force of attraction is higher than their escaping tendency. Therefore, it is classified as solid. If you talk about the liquids, in liquids mutual force of attraction is equal to escaping tendency. Therefore, the things around us which have the mutual force of attraction is equal to their escaping tendency, we classify those things into liquids. In gases, the mutual force of attraction is equal to is less than escaping tendency. So, the gases move randomly in all direction because the mutual force of attraction is less than escaping tendency. So, generally in our campus, if there were less teachers at night study hours, we have many chances to escape from our study hours. In the same way, the gases have mutual force of attraction very less than escaping tendency. Friends, shall we move to the next slide? Yes. Friends, I think you are familiar with the physical properties of the matter. Once again, let me recall what are the physical properties of the matter. If you talk about the solids, solids have a definite shape and definite value. For example, Let I take the bowl. So we are calling bowl as a solid. So I am keeping this bowl on the table. So it doesn't change its shape, it doesn't change its value. So solids have a definite shape and definite value. So solids are rigid. These substances, solids have strong intermolecular forces. If you see the picture of solids, the arrangement of particles in very closely, they are closely packed. The distance between the particle and particle is very minute gaps between the particle and particle. Therefore, solids have a strong intermolecular forces and short intermolecular distances. They are minute gaps between the particle to particle. Therefore, the solids have a short intermolecular forces, short intermolecular distances. Example, stone, diamond and pen, etc. and etc. In liquids, liquids occupy the shape of the container and definite value. For example, if you consider water, so water has a definite value but not fixed shape. If you pour water into the bowl, it does the shape of the bowl. If you pour the water in water bottle, it gives the shape of the water bottle. So the liquid has a definite value but indefinite shape. The substances less intermolecular forces compared to solids. The liquids have a large intermolecular distances compared to the solids. For example, water, milk, gasoline, etc. and etc. Friends, if you talk about the gases, the gases have indefinite shape and indefinite value. The gases have much less intermolecular forces compared to solids, liquids. Therefore, in solids there is very less intermolecular forces. That's why the gases move in all directions with a high speed. Because of the intermolecular forces are very less. They have a high freedom to escape anywhere. So on the basis of these intermolecular forces, it has less intermolecular forces now. Therefore, the gases are highly compressible. Today in this modern society, we are using LPG gas and CNG gas. This is because of the compressibility factor of the gases. So these are the physical properties of the gases. For example, for the gases are oxygen, carbon dioxide, air, etc. and etc. These are the examples for the gases. Friends, shall we move to the next slide? Yes. Gaseous laws. This slide may arise you many doubts in your minds. So in previous class, you have studied about Newton's gravitational law, laws of motions, etc. and etc. But what is gas laws? What do you have in the gas laws? Friends, let me tell you what are the gas laws. In general, the behavior of a student in campus governed by certain rules and regulations, right? In the same way, the behavior of gases governed by certain laws. We call those laws are called as gas laws. The gas laws are experimentally studied and proved. The gas laws give the relationship between the measurable properties of the gases. Friends, let me tell you what are the measurable properties of the gases. Yes. So here we have a list of measurable properties of the gases. They are mass, volume, pressure, temperature. The gas laws give the relationship between these four measurable properties of the gases. We can mass of the gas, we can measure the volume of the gas, we can measure pressure and temperature of the gas. The gas laws give the relationship between the mass, volume, pressure and temperature. Friends, shall we move to the next slide? Yes. Boyle's law. So what's Boyle's law state? Boyle's law state that at constant temperature and fixed number of moles of gas, the pressure of the mass of the gas is inversely proportional to volume. Pressure is inversely proportional to volume. It defines that, so pressure is inversely proportional to volume. It states that if we increase in pressure, if we increase in the pressure of the gas, there is a decrease in the volume of the gas. So if we increase the pressure of the gas, there is a decrease in the volume of the gas. So friends, let us do a small experiment to prove the Paul's law. I take a syringe. It is a 20 ml of gas. Friends, we know that gas is everywhere. Inside this syringe, there is the presence of gas. Inside this syringe, there is the presence of gas. So I am closing this mouth with my thumb, right? I am closing this opening with my thumb. So I am applying pressure on the piston of the syringe. So as I am increasing pressure on the piston of the syringe, the volume of the syringe is decreasing. What happening? As I am increasing pressure on the piston of the syringe, the volume of the syringe is decreasing. As more pressure we apply on the syringe piston, the volume of the syringe decrease simultaneously. So if we apply more pressure on the piston of the syringe, there is a more decrease in the volume of the pressure. So for example, so here I am applying some pressure, some 10 atmospheres of pressure on the piston of the syringe. So here the volume decreases to 20 ml. If I increase more pressure on that, the volume decreases simultaneously. So it states that if we increase in the pressure, there is a decrease in the volume. So if we increase in pressure, there is a decrease in the volume. From this experiment, we can generalize that as pressure increasing, the volume is decreasing. As pressure increasing, the volume is decreasing. So we can write that pressure is inversely proportional to volume. Pressure is inversely proportional to volume. So if you remove the proportionality constant, we can write that PV is equal to constant. Here P is the pressure, V is the volume, and K is the proportionality constant. Friends, have you ever observed the scuba diving travelers carry a cylinder with them? Can you guess what would be the reason to carry? Of course, the reason behind to carry is, so as we go down the water body or as we go down the ocean, the pressure inside the ocean is increases. As pressure increases, what will happen? The volume of the cavities decreases. The volume of the lungs of the cavities decreases. As pressure increases, the volume of the cavities of lungs decreases. Due to this, so sudden increase and sudden decrease in the pressure of the decrease in the volume of the lungs of cavities, it leads to many problems regarding to the lungs. To overcome such problems, the scuba diver carry a cylinder with them. It is the one of the applications of gas law, Boyle's law. Friends, if you observe the graph of the Boyle's law, Boyle's law graph, the graph plotted between pressure and volume at constant temperature. The graph drawn at pressure and volume at constant temperature is called as isotherm graph. So volume taken on the x-axis and pressure taken on the y-axis. So if you observe the curves T1, T2, T3 curves, at T3 curve there is a more pressure. If you observe the T3 curve, there is a more pressure. As more pressure, there is a more temperature. From this graph, we can say that a T3 curve has a more temperature. So temperature T3 curve is greater than T2 greater than T1. This is the graph of the Boyle's law. Friends, shall we move to the next law? Yes. Charles law. So what Charles law state? Friends, let me tell you what Charles law state. Charles law state that at constant pressure and a fixed number of moles of gas, the temperature is directly proportional to volume. It states that as temperature increase, the volume of the gas also increase. If we increase in the temperature of the gas, there is increase in the volume of the gas. Friends, let us do a small experiment to prove the Charles law. I take hot water. In this I am pouring in this bowl I am pouring hot water. Friends, as per the Charles law, so if we increase in the temperature, there is an increase in the volume, right? Let's do a small experiment to prove the Charles law. Here I take a water bottle and I am closed this opening with a balloon. Friends, we know that so heat always transfers from the hotter body to colder body. So we consider this bottle at room temperature. So I take a hot water in this bowl. So the temperature of the bottle increases as we kept in the bowl. So as we kept there is a expansion of the balloon. So here friends, here if we increase in the temperature, there is increase in the volume. Instead that if we increase in temperature, there is increase in the volume. Friends, if you write from this experiment, we can generate that temperature is directly proportional to volume. Instead that as temperature increase, the volume also increase. As temperature increase, the volume also increase. From this experiment, we can write that temperature is directly proportional to volume. So we can write volume is also directly proportional to temperature, right? So we can write that V is equal to KT, where V is the volume and K is the proportionality constant and T is the temperature. Friends, have you ever observed the air-filled balloon kept in sunlight burst out? Can you guess what would be the reason to burst out? Of course, it burst out because the air-filled balloon kept in sunlight, as temperature increased, the volume of the balloon increased. As temperature increased, the volume of the balloon increased. So after some limit, the balloon is burst out because the temperature increased, the volume of the balloon increased. So after some time, after its limit, the balloon is burst out. This is the reason behind to the balloon burst at temperature. This is the application of the Charles law in our daily life. Friends, if you observe the graph of the Charles law, the graph drawn at a constant pressure and the volume and temperature. Temperature takes on x-axis and volume takes on the y-axis. So if you observe the curve at P4, there is a more volume. At curve P4, there is a more volume. So at P4 curve, there is a more volume. Therefore, there is less pressure. So if pressure has volume increase, the pressure decrease. Therefore, at P4 curve, there is less amount of pressure. There from this graph, we can say that P4 curve is greater than P3 curve greater than P2 curve is greater than P1. This is the graph of the Charles law. Friends, shall we move to the next law? Yes. Avogadro law. What's Avogadro tells? Friends, let me tell you what is Avogadro law. It states that at the same temperature and pressure, equal volumes of the gases contain equal number of moles of gas. So it says that as volume is directly proportional number of moles. Friends, let us do a small experiment to prove the Avogadro law. Here I take two conical flasks. In this two conical flasks, I take equal volumes of acetic acid. In white color balloon, I take sodium bicarbonate. In pink color balloon, I take sodium bicarbonate in less amount. In this case, I take more amount of sodium bicarbonate. In this case, I take less amount of. So I am adding this sodium bicarbonate into acid. I am adding sodium bicarbonate to the acid. Friends, here when sodium bicarbonate reacts with acid, so there is the evolution of carbon dioxide. So in this case we take more grams of sodium bicarbonate, there is the evolution of gas is more. In this case we take less amount, there is a less amount of expansion of the balloon. From this experiment we can say that volume is directly proportional to number of moles of the gas. So we can write volume is directly proportional to number of moles of the gas. So we can write V is equal to Kn. So it can be written as V by N is equal to K. So it can be written V1 by N1 is equal to V2 by N2. Friends, if you observe the graph of the Avogadro law, so as volume increases, the number of moles of the increases. This is the graph of the Avogadro law. So ideal gas equation. Friends, if you combine all these gas laws, we get the ideal gas equation. So volume is directly proportional to Nt by P, where V is equal to Rnt by P. So R is the universal gas constant. So this is the ideal gas equation. So as we discussed, the conclusion is, so we discussed the Boyle's law, pressure is inversely proportional to volume at constant number of moles and temperature. Charles' law, volume is directly proportional to temperature at constant pressure and number of moles. Avogadro law, volume is directly proportional to number of moles at constant pressure and temperature. So we have discussed the ideal gas equation, PV is equal to nRT. R is equal to a universal gas constant, that is R is equal to 3.14 joule mole kiloinverse. So here, so we have learned many things in this session. So today I am standing at the T-shirt channel very proudly. It is because of the Dr. R.S. Praveen Kumar sir and our RCO Nagarjuna sir and our beloved principal Lakshma Reddy sir and our training, my guide teacher is Srikant Reddy sir. Because of this person today I am here standing, and my special thanks to the T-shirt channel and my friends who are supporting me. Thank you one and all.